Hello and welcome back. So now that we know how to differentiate, we can use this knowledge to find the extreme values of a function, which are just basically the highest and lowest points of a function. So let me give you an example. Let's say let me draw a graph up here. Let's say we were looking at the function y equals x on the interval from 0 to 5. So the graph would look something like this. It's just y equals x. And so in this function, we know that the highest value of this function on this interval is 0, or the lowest value is 0, and the highest value is 5. Say this is 5. This is 0. And that's pretty simple because it's a straight line. But what if we had a function that looked like this? That, again, we were looking from 0 to 5, but it went up, then it turned down, and then it ended right here. And we're still looking at, let's just call this function f of x. And we're still looking at it from 0 to 5. So in this function, you can see that obviously the highest point of this is not 5. And the lowest point is still 0 in this, but the highest point is not 5. So we know that the derivative actually gives us the tangent line, the slope of the tangent line at any point in a graph, or any point in a function. So what would be the tangent line at this point? The tangent line at this point would be a straight line. In fact, the tangent line at this point would also be a straight line. So the tangent line at any point, and this is called a critical point. And so is this. This is called a critical point. And a critical point is just where the graph of a function, or where the function changes from going up to going down, or from going down to going up. So in this graph, the highest point is actually one of these critical points. And with our knowledge of derivatives, we know the slope at any point in a graph. And the slope at this point, as you can see, since it's a straight line, the slope is going to be 0. So to find these critical points, we can use f prime of x. And at every point that f prime of x equals 0, we'll get these critical points, because there'll be a straight line and it's a peak or it's a dip. We'll just know that based on the derivative. So we can use our knowledge of derivatives, and we can not only test the endpoints of a function, we can also test every critical point in a function, and then the highest we can figure out, we can go back and plug these values that we get out of this back into the original function, and the highest of those values is going to be the absolute maximum, and the lowest of those values is going to be, which is actually right here, is going to be the absolute minimum of the graph, or of the function. So in the next video, I'm going to do an actual problem that's similar to this, where we actually find the derivative, we find the critical points, and then we use our knowledge and to plug this back into the original function and figure out the absolute maximum and the absolute minimum of any function. So if you have any questions, you can email me. I think if you watch the next video, it'll be a little more clear, because I'm going to actually do a problem like this. And so, yeah, keep watching. Again, if you have any questions, just send me an email.